Alright class, we're looking at hyperbolas today. Here's one general standard form of a hyperbola. We have x minus h squared over a squared and y minus k squared over b squared equals 1. The only difference between this and ellipse is there's a minus sign. This equation works when we're oriented left and right. The center is going to be here at HK. The vertices are going to be here and here at H plus or minus AK. So this distance is A. I guess I could get that a little more accurate here. This distance, right? Whoops, that's a whole eraser. This distance from vertice, from center to vertice, is A. It's the same as what it was in the last. So A equals distance from center to the vertices. C, distance from center to foci. Okay? So here's the equation for foci, and they would be in here. This distance from the center to the foci is C. This is the relationship between A squared, B squared, and C squared. And we'll talk about this on Monday, but this is the equation of the asymptote when we're oriented left and right. Okay? How about when we're oriented up and down? Alright. This is the equation when we're oriented up and down. This time the A squared is under the Y. The B squared is under the X. Okay? Oriented up and down. The center is still at HK. The vertices are now at H plus A and H minus A. So this distance right here is A. The foci are here and here. Okay, those are a distance of C units away. And again, same formula relates: A squared, B squared, and C squared. This is the equation of the asymptotes. All right. So example number 1. We're given the foci are -1, 2, and 5, 2. So these are the foci. The vertices are 0, 2, and 4, 2. Okay, so those are where the vertices are. Well, how is this oriented? If I graph this real quick, I got vertices at 0, 2, and 4, 2. So, and my foci are at 1, 2, and 5, 2. Oh, this is -1, that's why. -1, there we go. So -1, 2, and 5, 2. So, okay, here are the foci, right? And here are the vertices. Okay, our hyperbola goes through the vertices and wraps around the foci. So we're oriented left and right, okay, which means we're going to have x minus h squared over a squared minus y minus k squared over b squared equals 1. Okay, whoops. So where's our center? Well, our center is right in between these 2 points or these 2 points. Okay, our center is going to be right here. It's not drawn here. Right there. That's between, so 0, 2, and 4, 2. The point between those is 2, 2. So h is 2, k is 2. So x minus 2 and y minus 2 equals 1. A is always the distance from your center to a vertex, either one. Say this center is 2 units from this one. This center is also 2 units from this one. So A equals 2. So I'm going to put a 2 down here and square it. Okay, now we're looking for b squared. Well, we know there's a relationship between a squared, b squared, and c squared. This is 4. We don't know b squared, but we know c squared because c is the distance from your center, again, to one of your foci. So that's c is going to be 3 because from 2, 2, from this point to this point is 3 units. So I'm going to put a 9 here. B squared is then 5. This is example 1, and this is your answer for example 1.